Was it sorry, 10%?
I think it's 10%, but it...
It's significant 10%. Then
I'm gonna repack my hair.
okay, significant 10%. Thank you.
Make it sweet.
And then
God, I
that's
wanna
0.1.
go bold.
Do you have a side party?
0.1. Therefore,
Are you crazy? Why did you set me up?
rejects X0 females.
Huh?
There is evidence. There is
I
sufficient
kind of like
evidence
it though. You should
to
have a side
suggest.
party.
Wait, you're saying I have a side party?
Yes.
I'm joking. Stop
Evidence
lying.
Not lying.
to suggest
Do you not see?
I feel like it's because my head's tilted.
To see how it goes down.
females are
Shut up.
more likely to
I love this brush.
comply.
See, it's a
Yeah.
side party.
Okay.
You need to shut up. You get slapped.
Then
I really like this brush.
we're not really talking to males there.
Get it from the hair shop.
So I've kind of got a little bit off topic
From
there
where?
with that question. But it's
Hair shop.
quite a nice little question
Okay.
to recap what we were doing last lesson. That sort of makes sense?
Yeah.
Yeah? Okay. We can get the critical value if you wanted to by going into the Distribution Act.
Just be like,
Distribution
I
Act,
didn't meet on my
selecting the
birthday.
chi option,
20th September.
chi option there.
Okay.
Plugging in
Yeah.
to execute on degrees of freedom of 1. Execute probability of point
Hello?
1 there. And the chi-square value
You added me on.
2.75. Yeah?
I think you
This guy.
Right.
You know,
2.75.
it can just be practice.
Right. Keep knowing though.
Less than 11.75. You can put the snip in there. You see.
Is that necessary to write 2.7?
I would get the critical chi value.
7%.
I would never actually use it because 9 times out of 10 you can
Put that X
P
right
value,
now.
the P value goes in.
The
But
tiny
masking
people that
will
always
have
put
it,
X's.
okay? And because you can get it very easily, all you do is go into the Distribution App. All you do is go into the Distribution App and plug in the relevant significant level of probability. You write that down somewhere. I wouldn't bother you wouldn't bother use it, but Mark Scheme will have it. So you might as well get the Mark Scheme mark. If you can get it easily, you might as well do. Okay? There's no harm in writing the critical value down. Okay? The Mark Scheme don't realise that the calc does this. And I very much doubt that the people writing the stat table exam
Yes, it is. Oh, sorry, I've got to pull down.
No, look, I just put
don't know
the,
this exists, so hopefully
I pulled it over here.
If they offered you a job, would you take it?
No, I went for a job writing from Yale.
It's a t-shirt brand.
Can we see how this stuff is said again? Oh, t-shirt, right? Yeah, I'm wearing one right now. This is a t-shirt.
Yeah, look, if you just,
Let's
I've
go.
looked out for somebody in
if you just
Excel.
put it like that, it's gonna live.
Okay, yeah.
And then she said, no,
Right.
I've never done
Wait,
it.
why are we here like... That's my job. I'm gonna get away class. I'll read it.
So the people
So the people
Wait, can I
writing
see how
down,
this guy looks
I
like
very much
again?
doubt, looking at the
Yeah.
stat papers that come out so far, I might be wrong.
maybe we'll see the one that
general
they did this
opinion
year.
of examiners is they
But
don't
half
know what
cycle must be so
the
hard for you.
stat
It is,
mode
because
is.
sometimes
That's
it's
no-
just
No,
want
it's
to
good
be
that not to be like
So yeah,
this,
it's
you
good.
get
It's
Why
good
is
for
it
you
called
guys.
speed
You've got
baby?
higher
It
Right.
doesn't
Oh, he's silly. I mean, wait.
What a calculator can do and make
Right, so I'm hoping to see.
Oh, I thought he was Asian.
Hoping to
No,
see,
it's
but
okay,
as I say, you're the
Oh,
test year,
smooth.
the pioneers.
I
Yeah.
wasn't his
Well, they
mix.
did it last year, right? We're going to get last year's papers.
Oh,
back.
yeah, I'm
What do you
gonna
think?
give
I
you
think
last year's
Asian,
paper.
Latino.
Yeah, 'cause I'm excited.
Or black and Asian. Like Philippines and black.
I don't think
So,
it's black, babe.
Well, if you get it, it's
You
just
know.
like-
Yeah, everything that exists does not exist at the moment. So anyway, right, let's
This one's
get
so
back
good, man.
to
Let's go
the
around.
golf testing where we left it. Okay, and right, so we kind of got to
You need
just
to
making
take
more the
those
same
really
now.
long
I
pictures.
think this is kind of where we left it
That's my
with the colour of plants, and I think it's very
Because I-
better, wasn't it?
Mm.
Yeah. Okay. So you don't have to test just uniform distributions. You can test binomial distributions. You can test normal distributions. Possibly, all you do is calculate the expected frequencies with the relevant distribution. You compare that with the observed data. You do O minus E squared. Get your chi-test certificate. Compare it with the
Is your
appropriate degree
battery
of
going
freedom.
quickly?
Get your conclusion. Okay. You
So
can do any
now-
distribution. The only thing that's affected is, remember, anything you do from the observed data loses degree of freedom. So if you always
Let's
lose
take a
one
really for-
from the degrees of freedom
Okay.
because you
So I
always
can
know the
personalise
total that comes from the observed data.
Hmm?
Me
Okay?
too.
If you were
Because
to
we can't like just
calculate
personal birthday and call it a day.
like estimate
I mean,
the
I thought
statistic
that's how
binomial
that works.
distribution and you estimated the probability, the p-value from the binary distribution from the observed data. So you might find the average of the observed data, and then use the fact that expected is 1 over p for a Watson, something like that. That loses a degree of freedom. So you might be taking off 2 degrees of freedom depending on what you do from the observed data. Anything you do from the observed data loses a degree of freedom. Okay, so you always take off 1, but sometimes you might be taking off 2, okay, or more sometimes. Okay, binomial distribution then. So I think I did that one there. This one here. Flowers are in the ratio 9 to 6 to 1. Okay, we observed big flowers in the ratio 9 to 6 to 1.
I know.
Okay, we've got 410 red flowers, 320 pink flowers, and 70 white flowers. Are they in the ratio? Is there evidence to suggest they're in the ratio 9 to 6 to 1? Okay. So there's 450 flowers in total. There's 450. 800 plants there in total, sorry.
If I have
Okay, 800 plants in the ratio 9 to 6 to 1.
Oh.
Lucy? In the ratio 9 to 6 to 1. You've got 800 flowers, in the ratio 9 to 6 to 1. There'd be if it was in the ratio 9 to 6 to 1, the expected would be 450 to 350. Because 1 part of 9 to 6 to 1 is 16 parts in total. I've got 800 plants, so 1 part is 50. So 1 part is 50, 6 parts is 300, and 9 parts is 450, yeah? Okay, so the expected values are that if it's in the ratio 9 to 6 to 1. There's my observed values, O minus E squared, blah, blah, blah. Put that in your calculator. So use the GOF testing, list 1, list 2, etc. Go through it there. You get your degrees of freedom is 2 because I've got 3 rows, minus 1 because I knew the total. Your degrees of freedom is 2. My p-value is pretty unlikely there. Okay, that's significantly less. We're testing at the 1% level. That's significantly less than 1%. The 1%, that's less than 1%. Therefore, reject H0 is evidence to suggest conditions have changed. So you can test ratios. Okay, does that make sense, everyone? Yes. Let's move on. Okay, so we can test the binomial distribution. See if the binomial distribution fits. Okay, so here's next example is a binomial distribution. Okay, right. Okay, if you're given the 2 parameters in the binomial distribution, you're given that if I think a binomial distribution with 6 with 100 rolls, 5 rolls and 1/6 the dice is fair fit, and I'm given those parameters there, I just take off 1 for the degrees of freedom. Okay. If I have to estimate P from the observed data, which is the thing you could do, I would take off another degree of freedom. Okay, so we're going to do examples. Okay, so here's an example.
Or at least can we try go to the one you need?
Okay. I'm going to work through this on the calculator. I need to work through this a little bit. Okay, number of 6s. What we're doing is we're going to roll the dice 5 times. I'm going to count the number of 6s. Okay. Right. We could get in that roll of dice. We get no 6s, 1 6, 2 6s, 3 6s, 4 6s, up to 5 6s. So we roll the dice 5 times. We get from 0 to 5 6s. Okay. We're going to do that again, and we're going to count the number of 6s again. Okay, if we roll the dice 5 times. We're going to roll the dice 5 times again. We're going to count the number of 6s. We're going to roll the dice 5 times again, count the number of 6s. We're going to do that process 200 times. We're going to do 200 lots of 5 rolls of the dice. Okay, and every time we do 5 rolls, we're going to count the number of 6s we got. Okay, and when we did that, we've got 66 times we had no 6s, 82 times 1 6, 40 times 2 6s, 10 times 3 6s, 2 times 4 6s, and no, we never got 5 6 6s. Okay. Okay. The question we're asking is a binomial distribution of 5 rolls and 1/6 fair dice a good fit? So if we roll the dice 5 times and count them 6, we've got a binomial distribution of 5 successes up to 5 successes. We've got a binomial distribution of 5 and a 6. We're going to test whether a binomial distribution of 5 and 1/6 fits the dice. We're kind of testing if the dice is fair, but we're using up 5 rolls of the dice. If the dice is fair, binomial distribution of 5 and 1/6 for the 5 rolls of the dice would be a good fit. Okay. And H1 is not a good fit. Okay. Right. We're then going to calculate our expected frequencies for if the binomial distribution is a good fit. What would the expected frequencies be for getting no sixes, and we can calculate the probability that x is equal to 0 of 5 rolls. We can calculate the probability x is 0 by using 5 choose 0, p to the power of 0, q to the power of 5. Then the probability that x is 1 would be 5 choose 1, p to the power of 1 times q, or 1 minus p to the power of 4. X is 2, the probability would be 5 choose 2, p to the power of 2 times q to the power of 3. Okay? Or you can use the NPR button on your calculator. The x is equal to value on the calculator to get the probability. Okay, so you can use the NPR button on your calculator to work out the probability x is 0, 1, 2, 3, 4 and 5. Does that make sense? Yes? No? So we've worked out the probability. If we know the probability, we can work out the expected frequency by simply timesing the probability by the total number of rolls, in this case 200. Okay, the total number of sets of 5. So we can work out the probability x is 0, x is 1, x is 2, x is 3, x is 4, x is 5, and then times that by 200. I've just talked for a lot of calculation there. Obviously the calculator all for you in one hit. Okay? So that's what we're going to be doing. So let's work out the probability x is 0. And what we're going to do, we're going to get the calculator to perform the probability. So I'll just go through that in the last 5 minutes. Okay. So what we're going to do is, I'll put the screenshots up here. Going to go into... what we're trying to do is, rather than doing, this is where I suspect you get some serious